I think I heard it, semilog y. So the reason I would use semilog y, because I want my y-axis on a logarithmic scale. Now, another thing that we'll notice here is that this line is actually linear, right? If it's linear on the log scale, that means some very special things about our relationship. So why don't you guys give this question a try, and then we'll go over the answer and also how we get there reliably. All right? Now, everybody sees this relationship here, right? So this is the form that our relationship is going to take on a semilog y graph. You can see that our output, our dependent variable, is the logarithm, and then we have a linear relationship on this side. So if we, well, no. So we're asked to solve for the relationship between n and y, right? Which means that we want to isolate n. You guys all remember exponentiation from like algebra? It's when we can take the exponent of both sides, right? Or we take both sides to an exponent. No? So what we can do here, we have log base 10 of n is equal to ay plus b, or ay plus b. There. Then we'll take 10 to the both sides, like this. We will have this equation, 10 to the log base 10 of n equal to 10 to the ay plus b. These cancel out when you have a logarithm in an exponent. So we will get n on this side, and then using our properties of exponents, we can separate this into 10 to the ay times 10 to the b. Then in our answer choices, we'll actually turn this into a constant k. So n is equal to k times 10 to the ay. Does this make sense to everybody?
Yes. So, right, and see why for this, right? That should change, yes? There's no actual, so we just call it constant. So that's what we call it.
Another reason, right, that number is, since b is itself is a constant, we can actually just, for simplicity, rewrite that entire 10 to the b as a constant. Now, we can also show you this relationship in MATLAB. Okay. So let's say that I have x from 0 to 10, and I'll take my y as 4 times the exponent of, like, let's say 2 times x. And then I'll plot this on a semilog y graph, right? Same as we did in the question. Semilog y. Here's the figure that appears, right? You can see it as a line as expected. And then if you look over here, y-intercept, right? I'll click on this, and what do you know? It intercepts the y-axis at y equals 4. Where does y equals 4 appear in our expression? It's this number that we multiply by.
The constant?
The constant, yeah. So, does this relationship make sense to you guys? Okay, cool.
What would the graph y look like?
Oh, on a regular plot? Sure. It's just an exponential.
Okay.
You can see right here. Standard exponential. Does anybody want to guess what looks like a line on a semilog x graph?
Yeah, you're not gonna get it.
A logarithmic.
Very good. Actually. A logarithm. So we do y is equal to 4 times the log of 2 times x. And then we do semi-log x of x comma y. Our function is once again a line. Now, this time it doesn't intersect at 4 as expected. This is because the properties of logarithms that I didn't account for. But the point still gets across.